Every time that we do updates, it always screws up how this program works. Okay, so let me go ahead and oops. I guess I should. I am sharing. Okay, good. Okay. So it's still doing the same thing. Even though I'm logged in. Yeah, I think I'm going to get another program. Okay, let me try another browser. Keeps logging me out. I don't get that. Oh, that's weird. Now it's logged in. I don't get that. Maybe it's because I'm not patient enough. Okay, so it just ignored what I told it to do. Try this again. So transform. So I uploaded it the wrong way. Let me see if I can get it to be fixed. Okay. So after a while, I got it to log in, to come in. So, and were you able to do this part, Trixie?
Yes, doctor.
So you were able to get it to upload and everything?
No, not yet, sir.
Okay. So in this case, what we're going to do, we're going to go ahead and hit calibrate.
Mm-hmm.
So we're going to go ahead and hit apply. So what's going to happen is it's going to give us our blue 2 and our green 2. Okay, so these are two wavelengths. This is approximately what they were. And so we're going to do this by aligning with our eyes because that's the best we can do. We're limited by the equipment that we have. It's not showing. Okay, I'm gonna try again. Calibrate. Okay, so it says I already calibrated this program. So let's see. I don't know if I did, but it says I did. So we're going to clear our calibration. So so we're going to go ahead and clear this. And then we're going to try again. So let me read what it says. I don't know how it successfully calibrated because I didn't put the limits there.
Do you want me to try on mine, doctor?
Yeah.
Okay, I already transferred the pictures here in my laptop. Can I share my screen? Because I don't know. I
Let
don't
me
know
stop
why.
sharing. I have to stop sharing mine. Now you can share yours. Yes.
Can you see my screen, doctor?
Yes.
Okay, so what do I need to do?
Okay. So if you go to tools up top, it'll say community tools. Yeah. Go down to Spectrum Workbench. Yeah, it's doing the same thing for you as well.
Yeah. It's not working.
Yeah, I thought I would have it already figured out. I thought my update was working.
Me
And
too.
then yeah.
I'm sorry, doctor.
No, it's not your fault. It's the program. There's nothing you can do. There's nothing we can do on it.
Um,
Let me see if I can find another program
okay.
to use.
Oh, doctor, it worked for me. Hold on, let me share my screen.
Oh, it did? It just took a minute?
No, I tried it again.
Okay.
The Google. Hold on. Right here, doctor. Um,
Okay, make sure you unclick. You see where it says, is your image vertical, up and down, or is it horizontal, left to right?
oh, okay. It's left to right.
Okay.
Okay. Um, what do I need to put here, doctor?
You can put anything, whatever it was that you were looking at.
Like it's
Just to
for
remind
example,
you, really.
the
What was that?
like for example, it's from the white flash. Is that
Yes,
it?
so then you would say white light, yes.
Okay. And that's it. Oh no.
Okay, what happened?
I don't, doctor. It says
It just restarted on its own. Let me try now. Try something different. Okay, so it's not working correctly.
oh.
So it's not just, let me see. Let's try cross sections. Okay, there we go. Let's see. I think I got it. Okay. Yes. Okay, so I think I figured it out.
Okay.
Okay, so it's having a lot of trouble because there's a lot of other things that are going on, like my red writing up here. And so it's trying to figure out what is it that I'm looking at. And so it's
Oh,
having a hard time finding what it is that we're looking at. So I'm gonna go back, get rid of all of this. So trash this. We're gonna trash this. Okay, so I also changed it to a device, so I have it my smartphone because I use my smartphone to take the picture. So it's not the prettiest picture in this case. So then what I've done is I went down here and I hit cross section. So I set a new cross section. So this pops up, and then what I did, I click on my image where I wanted to set the new cross section.
sorry, doctor. I can't see the screen.
Oh, sorry, I'm not sharing. Sorry.
No, it's okay.
Okay, let me go back. Okay, cancel. Okay, can you see my screen now?
Yes.
Okay, so I'm gonna have it. Oops, I keep doing that. Okay, so you see my image is up there, right? So I had to import my image, but I had it imported by using it said it was a smartphone device,
Okay.
okay, that I used to take the image. So then I'm gonna go down to set my new cross section. And then I'm gonna click on my image. So I'm gonna click it so that it's in the middle of the spectrum. That was too high. Okay, right there. And then I'm gonna hit apply. So it's basically helping the program find out where your spectrum is at.
Okay.
And then you're gonna hit calibrate. You're cursed. It's just struggling with me. Okay, so try again. So cross section, new cross section. Then we come up here to the image and we hit in the middle of it. Hit apply. Then we hit calibrate. Okay, so when we hit calibrate, you're gonna have the green and the purple. So then what you wanna do is you wanna line it up to your green and your green and your blue, not your purple. Green and blue. Okay, so, and then you hit apply. Okay, so this sets the calibration. And then you can see, okay, so this is my blue line. This is my green line. This is my red line, right? And so you can get the range of, okay, so the blue is from here to here. The green is from here to here. And then the red starts somewhere over here. Okay,
Okay.
you see that? And another way of looking at it is, so you see this blue peak. So this here represents that blue, right? This here is the green. And then here's the red. This up here is the red. Okay, so that's going to give us our range, right? In the wavelength. So our blue range is going to be from 405 to 501. Our green, which I guess our green and our blue kind of overlap, is going to start at like 492 to like 559. And then our red is going to be from here to here. Okay. So what we want to do is get the range of the different colors the major colors that we see. So primarily we can see the blue, the green, and the red. I should probably put that in the lab. Okay, so we're going to set up a Google Doc. Like this. Give me a second.
Sure.
It's been a long week.
I know.
Usually when I get home, I'm so tired. And I'm like, okay, I'm gonna get this done, I'm gonna get this done, and I'm gonna get this done. And I don't get any of it done. Okay, now I can't get into anything. Okay, Drive, Docs, Sheets. Okay, so we're gonna set up a Google Sheets. Okay, we're gonna have a blank one. Okay, so what we're gonna do is we're gonna focus on the ranges. So the first one we're gonna have is the blue range. We're gonna have the green range. And we're gonna have the red range. Okay, I'm gonna slide this over. Okay, this is going to be the item that we looked at. So we're looking at, let's say, okay. So the first one I looked at was a nitrogen bulb. Okay, so let's see, the range was basically starts at, go to a peak. Let's go, we'll take the peak. So it's at 414.9. This is going to be in nanometers. Oops. And so this is going to be the beginning of the range, and this is going to be the end of the range. So it starts to drop off around 499.2. Okay, so we're going to fix up our table a little bit. So that's me. So if I remember how to do this. So we're going to merge the cell. Slide this over. Green range in nanometers. We're going to merge those cells. There we go. Format cell. I have red range in nanometers. Okay. Okay, so what we're going to do, we're going to put these photos next to each other. Okay, so if we take a look at this. So what we're going to do, I'm going to mark up on my image, and then I'm going to enter all the data over here. Okay, so here we have, so we have our spectrum, right? And sorry about that. Let's see, annotate. Okay, so you see this represents the blue right here. So we're going to basically go where all the blue's at. Okay, this here represents our green. This is where the green starts to come up. And it goes all the way up to here. And then this here represents our red. Right here. Okay, so you can see the lines. Can you see those lines? Those really light red line. Here you see the blue line. Yes, no, maybe?
Yes.
Okay, good. Okay, so that's going to be our blue range. So blue is basically going to be from 414.9 to 499.2. Our green is kind of funny. It has multiple spots. We have this green band here, we have this green band here, we have this green band here. And that's going to be represented by here. Right?
Yes.
Okay. So if we wanted to, we could sit there and break that down so that it's each of the different bands. And that's probably what we should do to be a little conservative. And so like we have, this one kind of looks like it's just one big old blue band, right? Where it really isn't. If you take a closer look, you actually do have the gaps. So, but we're going to be a little lazy today, and we're just going to put the range that we have, okay? So, mainly what I want you to get out of this. Okay, there we go. Okay, so then what we'll do is come over here. We're going to follow our green line. And that is at 503. So we're going to enter 503 over here. And then we're going to go all the way past to looks like 592. Okay, then we're going to do the same thing with our red. So we're going to click over here. We're going to see where our red starts to peak up. So that's like at 581. And then, which is weird, it's going to go down to 672.2. Okay. Okay, so this is going to give us our wavelength. right? For that sample. So both of these are wavelengths organized so they look like my graphs. So what do you think of the class so far?
Sorry, doctor.
I said, what do you think of the class so far?
Oh, a little hard.
A little hard? So are you naturally an online learner? Is that what you do normally?
No.
No, me neither. As you can tell, right?
Yeah.
Because I keep making a lot of silly mistakes trying to get everything up
I
online.
know.
Yeah. And I know it makes it probably drives you guys crazy, but it's a
Yes.
process.
You're not used to it.
Yeah, I'm not used to it either. Yeah. And I'm used to seeing my class, seeing the people that I talk
Yes.
to, and it's so weird not having people come to class. That's okay. So now that we have it all worked out, and we'll make the grid lines and all that stuff here, right? So this gives me my low end range, and this gives me my upper end range of the wavelength. So all of this is be representing our wavelength. I'm gonna put wavelength up here. Range. Red, green, and blue. White. Okay. We're going to just go ahead and merge this. So we're going to go to formatting, merge cell, merge all, and then we're going to set it. And we're going to make it bold. Okay. So this here is going to be where we're going to keep track of all the wavelengths. And so we're going to sit there and use Excel to do the calculations for us. So in lecture, I don't remember if I talked about it yet. I don't think I talked about it yet. I think you guys are okay. So we'll be talking about it here shortly. So we're going to be calculating the amount of energy there is, and we're also going to be calculating the frequency. The first thing that we want to calculate is frequency, because we can use the frequency to calculate the energy, okay, produced in this range, okay? So what we're going to do is we're going to say the frequency, blue light, sorry, blue frequency. Actually, what we'll do is just copy this. So let's copy this. Copy. So it's nanometers now. We're going to have hertz. HV. Hertz is the units that we use to measure frequency, and it's going to be equal to the same thing as 1 over seconds. I thought we would be there already. And then up here, this with frequency. Okay. So to calculate our frequency, we use the speed of light. We're going to use this equation here. Put the equation in my box here. So we're going to use the letter F. Normally we use the letter nu, but we're going to use F for frequency equals, actually we just put out frequency equals speed of light divided by the wavelength. In meters. Okay, so and I'll be going over this in 30 minutes as well too. So if we don't get it now, that's what we're going to be doing for lab. And then you guys have a simulation for the next one.
Okay.
Okay, so what we need to do is change our frequency. Well, first thing we have to change our wavelength into meters. So the way that we would do that is we're going to do a generic form. So we have we'll say we're going to use X as our value. X, and the units are in nanometers. Okay, we want to change nanometers to meters. How many nanometers will equal 1 meter? Nanometers.
1 meter.
So how many nanometers will equal 1 meter? Yes, that's my question. Let me give you a hint. What number starts with the N?
Number starts with N?
Yes.
9.
9. So if I have 10 to the 9th power, I'm trying to use my mouse. Nanometers will equal 1 meter. Okay, so then nanometers are going to cancel out, and then we're just going to get X to the times, I should use X. Let me use another letter. It's a problem. We'll use Y. Okay. So then, keep forgetting that. Y to the times 10 to the 9th power meters. I mean, minus 9th power. Okay, since 10 to the 9th is on the bottom, we just take the inverse of that. And that means you have 10 to the minus 1. I mean, to the minus power, yes. Minus 1. Okay, so we want to try to type this into our equation so that it does the calculation for us. So we don't have to do the calculation because I don't know how many different things you looked at. You should have looked at your glow sticks, the light, and then some of the spectras that I was going to give you guys, okay, which is the light bulb. Okay, so in this case, what we're going to do is we're going to type in equal, maybe. We're going to type in the equal sign. We're going to type in the value that we have here. So we're just going to click onto this field here, which is B3. We're going to hit star, and then we're going to say 10 to the 9th. Okay, times 10 to the 9th. That's 10. And then we put caret in parentheses minus 9. Okay?
Okay.
And then this would give us our frequency. I'm sorry. This would give us our conversion. We're not done yet. Okay? So, sorry about that. So then this allows us to change. This is changing. Got ahead of myself. Changing nanometers to meters. So then we can plug this guy into our equation, where we have the frequency, speed of light over the wavelength, right? So if frequency equals the speed of light over wavelength, speed of light is 3.00 times 10 to the, I'm going to use my caret. Where's my caret? 10 to the 8th power. And it's meters per second. Okay. So speed of light is this, right? So what we're doing is we're going to divide the speed of light in this cell. Sorry, like I said, I already screwed up. By the wavelength. So we're going to put speed of light, which is B.00. Here we can use the E. This E represents exponent, so it's like 10 to the whatever, E8 divided by, we'll put this in parentheses, our value in the form of meters. And we're going to hit return. Okay, so this is going to be our frequency, but I want to have it in scientific notation. So I'm going to change my formatting for this guy. If I can do this. Let's see. Okay, right here. Scientific notation. Okay, so that calculates our frequency. Okay, and again, that's going to be hertz. A hertz is basically meters over seconds. So if we look at this number here, down here, the speed of light, keep doing that. So speed of light divided by, let's say y, x, 10 to the minus 9 power. And that's meters. Meters are going to cancel out, and then all we're going to be left with is 3.00 times 10 to the 17 over y. And that's going to be 1 over. So I heard 1 hertz. 1 hertz. 1 hertz equals 1 divided by 6. Okay. And that would be the units. Okay. So they're comparable to each other. Okay. So now once we've done that, this one, all we have to do to calculate all the rest is to drag it over because it keeps the same equation. Okay. The only thing that's going to be changing is the cell that the number is in. And so then that way we've calculated all of those without having to do all of the calculations. Does that make sense?
Yes.
Okay. Okay, so that's it. And then all you need to do now is you're going to do the same thing for all of the different ones that you have.
Mm-hmm.
And then, so you're going to have all your data, then you're just going to calculate the frequency. Now, we also wanted to calculate the energy. So I'm going to copy this here. And then I'm going to put energy here, so frequency. Okay. Okay, the way that we calculate energy so energy equals Planck's constant times frequency. Okay, and Planck's constant is, look it up because I can never remember it. Off the top of my head. Okay, and Planck's constant is 6.6261 times 10 to the 34 power. Sorry, minus 34 power. And the units are meters squared kilograms divided by seconds. Okay, so how do we use that? So what we're going to do is, you said it's the frequency, going to equal the frequency. So we're going to click on this because this is our frequency times times Planck's constant. So 6.6261. Then we use E, put it in parentheses, negative 34, back in parentheses, and then we're going to hit enter. Work out. Equals times let's try this. No name in there. Okay, let me try this again. 6.621 e to the negative 34. There we go. I don't know why I was having trouble. Okay, so then we just drag that across. And so then we've calculated the energy range for all of that, right? So as we take a look, as the wavelength goes up, so if we're going both as we go up on wavelength, the frequency goes down. As the wavelength goes up, the energy goes down. You see that?
Yes.
Okay, good. Okay, so what you're going to do is, that's pretty much what you're going to do. You're going to do that for your white light, and we're only going to focus on the blue, the green, and the red. Okay?
Yes.
What we're going to do is we're going to go down to Spectrum Workbench. We're going to go ahead and log in. And I always have trouble logging in. Oh, it worked this time. Okay, so I was able to log in with no problem. So then I'm going to go ahead and hit upload image because I took pictures with my phone and I sent it to myself. So then I'm going to go ahead and choose my file. Let's see. Okay, so I took a picture of a nitrogen tube, and that's the picture that I uploaded. Okay, now my picture was going from left to right, so it's vertical so then I'm just gonna, not vertical, horizontal. So I'm gonna deselect the spectrum is vertical. So it puts it in the right way. And then I'm gonna go ahead and hit upload and calibrate later. I got my title in. Nitrogen. So I connected it. I connect my spectrometer to my smartphone. So I'm going to go ahead and click that. Okay, there we go. Okay. So do you guys see it showing on my screen? Can you guys see that?
Yes.
Now the program is running a little slow and it's a little clunky, so it may take a little bit for it to finally get out there, as you can see with mine. So then what I'm going to do is, because I know this is not calibrated, I have to show, let me draw my, so this here is my right here. Just that part right there. Okay, so I have to show the program where the spectrum is so that I'm able to sit there and do calibrations. Okay, the way I do that is I go down here and I select set new process. So then I click in the middle of my spectrum. Okay, and it puts a line through it. Did you guys see that?
Yes.
Okay, good. Okay, so now once I click that, I'm going to hit calibrate. blue button. Okay, now when I hit calibrate, it's pop up 2 points that I'm going to use for my calibration. Now, if I have a blue and a green spectrum showing, I'm going to line this up to my second blue band and my second green band. Okay. And then I'm going to hit apply. Okay. That did not work. So we may have to do that one again. Just did this. It's just worked. So let me clear something. Okay, there we go. Okay, so what we're going to do, we're going to be looking at the blue light, the blue, the green, and the red. Okay, so what it does, it separates the blue, the green, and the red. So you see where we have the peaks of the blue? So right here to right here. And then we start getting the peaks of the green, which is about right here to right here. And then we have the peaks of the red. Let me put them in the perspective colors. So we have the blue here, blue, blue. Then we have green. There you go, green. And then we have our red over here. Actually, take a look, it'll be from here to here. Okay. Okay, so what we're going to do is we're going to find those values. So we're going to go along that blue line. We're going to find that peak where it starts to peak up. So here it says at 366.4. Okay. Do you guys see that? So as I run along that line, okay. And we're going to go that whole range. So we're going to go all the way to here where it starts to drop, which is going to be 447. Okay. So what I'm going to do, I'm going to start a Google Doc. Which I've already started here. So I'm going to type in what I'm working with. So we're going to have we're calculating our wavelength, the frequency, and the energy. Okay. So the very first thing that we want to have in column A is going to be the item that we're looking at. Okay. So in this case, we're looking at a nitrogen bulb. So bulb. We know that nitrogen is a diatomic. It's about 5 to 2. And I'm going to fix that so it is, so that shows correctly. Trying to remember, where is the formatting? I'll have to think about where the formatting's at, but okay. So into bulb, and then we're gonna put in that data. Can you guys see my screen? Gabby?
Yes. Yes.
Okay, so our peak is gonna start, say down here. So 363. And your values are going to be different depending on what you're looking at. If you have a full spectrum, like if you're having the full light spectrum, make sure you line it up with the blue and the green. And so it should be approximately right. Okay, so then 363, 3.38. Okay, and then it ends, starts dropping down here. So what? That's 451. Okay, so we're going to do the same thing with our green. So green starts over here. So 473.2. And it goes to okay. So it starts to drop at 547. And then the red, well, look at the red, it starts to pick up around the same time that the green starts to drop, which is at 547. And then it drops. Like at 639. Oops. Okay, so those are going to be my data points. Okay, so the next part is we're going to calculate the frequency. So the frequency is equal to the speed of light times wavelength. Let's see if I can fix this real quick. Hmm. Okay, so let's see. So the speed of light is equal to 3.00 times 10 to the, I'm using the caret, that little symbol to represent the exponent, 10 to the 8th, and the units are meters per second. Now, it says the frequency is equal to speed of light divided by the wavelength in meters. So this wavelength is in nanometers. So we have to change this nanometers into meters to be able to use it. So the way that we change nanometers into meters, we know that 1 nanometer, 10 to the 9th nanometers, will equal 1 meter. Okay, the way I remember that is that 9 starts with an N and nanometers start with an N. So anytime I think about nano, I know that that's 10 to the 9th of whatever unit that I'm working with. So for instance, if I'm working with grams and I'm talking about a nanogram, I know that 1 gram is equal to 10 to the 9th nanograms. Okay, you guys with me?
Yes.
Okay, so since I know that, I'm going to take that into account for my equation. So I'm going to try to set up my equation. I know that I have to get this guy into meters. So I'm going to adjust my equation so that I have this converted into meters. The way I convert things into meters is I always start with my given. So in this case, I'm going to say my given is y. So y is my given. And my given is in nanometers. So y nanometers. So I know that to convert that to meters, I need to divide by 10 to the 9th nanometers. And that's going to give me my meter. So this is going to be equal to y times 10 to the 9th, 10 to the minus 9th nanometers. Okay, so then I'd be able to plug it into this equation. So I have the speed of light, so which is 3.00 times 10 to the 8th power. It's meters per second. Sorry, that should just be meters. Okay, and then we have that divided by y times 10 to the minus 9 meters. Okay, so then meters are going to cancel out, and then we're going to be left with the units of 1 over seconds. Okay, so whatever this value would be, 1 over seconds. Okay, so now how would I write this equation for me, for myself, in terms of Excel? So Excel can calculate, Excel or Google Docs can calculate it for me. So the way that I would do that is I'm going to type in to this field the equal sign 3.00 E. This E means 10 to the whatever power we put behind it. So in this case, if we take a look at this, I'm going to simplify this because 10 to the minus 9th, 10 to the 8th divided by 10 to the minus 9th, that's going to be 10 to the 17th altogether. And then it's going to be divided by the value that we have here, our y, which is going to be our B3. So we're going to hit return, and that's going to give me my numbers. Now, this is a crazy looking number. I would like to have it in scientific notation. So I'm going to change my format to scientific notation. Okay. So now 1/seconds is also the same thing as 1 hertz. Okay. Okay, so now once I've done this calculation, I can calculate all my frequencies by just taking this in that blue corner, the top blue corner, and where I get that cross, and then just dragging it to the right. So then it does all my calculations for me. Kind of like what we did with the Mentos lab. Okay. So now once I calculate my frequency, I can use the frequency to calculate the energy. So if I wanted to calculate my energy, then all I do is hit equal, and the energy is Planck's constant times the frequency. Well, Planck's constant is going to equal 6.6 261 times 10 to the negative 34. And the units are kilograms meters squared kilograms seconds. Okay, so all I need to do is multiply the frequency times Planck's constant. So to do that, I'm just going to plug in 6 point to this first cell here, 6.6261 e to the negative 34. And then I'm going to put star, which means times. Then I'm going to drag over and click my H3 box. So that will be the very first blue range figure. And then I'm just going to hit return. And then, so then this gives me the energy. And we know the energy is in joules. So these units end up turning out to be joules. So we have seconds squared you have meters over kilograms per second squared. So that'll be the same thing as joules. And joules is a form of energy. Okay. Questions? Okay, do you guys need help importing your figures? Or are you guys good? Are you guys there?
Yes, I'm here. I think I have to go back and look at the other one, the other lab, just to make sure that I did it correctly. And then I'll
Okay.
be importing everything in.
Okay, sounds good. Brittany,
Yes.
so do you need help or do you got it?
I'm gonna do the same thing.
Okay. Okay, so next week, so right now I've just opened up a simulation. So you guys will be able to do that simulation. And next week we'll be doing a physical lab. So for your physical lab next week, this is what you guys are going to need. So I'll type it on the board. So next week is the 22nd. Oh, sorry. Today's the 22nd. Next week is the 27th, 29th. Okay, you're going to need sugar. You're going to need Epsom salt. You're going to need baking soda. Your aluminum pie tin. Water. Your scale. And an oven mitt. And access to your stove. Okay. That's everything. Okay. Questions? Okay, so then that's all I have for you today. So you guys have no questions. Blank, so wavelength and meters. Okay, it says, what type of light on the electromagnetic spectrum has the highest energy per photon? So if we take a look at this, this is our frequency, this is our wavelength. So as wavelength increases, frequency decreases, right? So that means that frequency is directly proportional to energy. If we take a look at what I just did, as the wavelength increased, the energy decreased, right? So they said the highest energy per photon. So what color light? I mean, what type of light? So, and here are our options. X-rays. X-rays are down here. Do you mind if I write on your screen? So we have X-rays that are down here. Yep. Okay. We have visible light, which is right here. That's E. So A, B, oops. All light has the same energy. Microwaves, that's C. And gamma rays, gamma waves is D. They should be gamma rays. So that's D. Okay. So which one is going to have the highest energy? So if we look at the equation, energy equals H nu. H is the Planck's constant. Nu is the frequency. Okay. So as the frequency increases, so if we get a bigger value for frequency, what's going to happen to the energy? Is it going to increase or decrease?
Decrease?
No.
Increase?
It's going to increase, right? So energy is going to increase. So the speed of light is equal to lambda times nu, right? Where lambda is the wavelength and nu is the frequency. So in this case, the speed of light is a constant, right? So we're basically saying that, I'm going to rearrange this equation. We're saying that C over lambda equals nu, okay? Now this number is always going to be the same, so it's never changing. This number changes. So if this number gets big, it's going to make this number small, right? Because it's 1 over that. If this number gets small, it's going to make this number big. Okay, so that means that as wavelength increases, the frequency gets smaller, which means the energy gets smaller. Okay, so the question that they asked us was on the what type of light on the electromagnetic spectrum has the highest energy per photon, right? So in that case, the one that has the lowest wavelength. Which one has the lowest wavelength?
C? The microwave?
No, the lowest wavelength. Look at the values. These are your wavelengths up here. This is your frequency down here. So this is 10 to the minus 11. This here, microwaves are 10 to the minus 3. Which one is a bigger number?
Well, which one has this one?
Okay, 10 to the minus 11 right here, or 10 to the minus 3. Which number is bigger?
10 to the minus 11?
Are you sure? Plug it into your calculator. So anytime, let me give you a hint, Gabby. Anytime that you see a negative, right?
It's lower.
That means it's going to be really, really small, right?
Yeah.
So for instance, 100. 100 is 10 to the second power. Okay? 1,000 is 10 to the third power. A million is 10 to the sixth power. Okay, So now we have negative, right? So 0.1 equals 10 to the minus 1 power. 0.00000 6. Okay, this guy is 10 to the minus 6 power. Okay, Gabby, do you make money?
Yes. No,
Okay.
well, yes.
So I'm going to pay you 10 to the minus 6 power for every hour you work. My rival will pay you 10 to the second power for every hour you work. Which one are you going to work for? Me or my rival?
For you?
Are you sure? So let me write that
To
down.
the 6.
So I'm going to write down what I said. I'm going to pay you 10 to the minus, the caret basically means the exponent. Can you see my typing right now? Do you see anything on the screen in green? Being typed. Minus 6. Can you see that? Does it show up now?
No.
What
Oh,
about
right.
now?
I can see it. I just have this right here.
Okay, so I'm paying you 10 to the minus 6, and my rival is paying you 10 to the second. Which one are you going to want to work for?
And to
Oh,
the
no,
second.
10. No, 10 to the 2, right? To
That's
your
right.
rival? Because it's not negative.
That's right, exactly. So anytime that you see a negative, that means that you're going decimal, right? It's going to be lower, really, really low. So we want it so that our frequency, so our wavelength is low, because that means that when our wavelengths are really, really low, that means our frequency is really high. And then that also means that the energy is also going to be high. So which one of these, A, B, D, or E, is going to be our answer, where we have the highest energy?
Am I looking at right here, right? Because this is the,
Okay,
oh,
so the top part here, I'm going to circle it in pink, maybe. This part here, that's the wavelength. This is 10 to the minus 11. This is 10 to the third. Now, I said we want our wavelength to be
the highest, so it's going to be this one.
No. We want our wavelength to be the lowest, right? Because that means that the frequency is higher, and that means that the energy is higher. So energy, and that's right, the correct answer is E, right? Because that's going to give us the lowest wavelength, but it's going to give us the highest frequency. And frequency is directly proportional, meaning it goes up. So as energy goes up, frequency goes up. As energy goes down, frequency goes down. Wavelength.
Are you recording this so I can look at it later?
Yes, I am recording this. Okay, so the correct answer, who said E? That is the correct answer. So let's go ahead and select E and then hit submit. Now I want to see what it does. Okay, so you're good. So just hit submit.
So I hit submit.
Okay, you're good to go. So it's not going to take any points off of it. Okay, normally it'll say.
It did. Oh no, it's good. But earlier when I did, because I had a 42, I had completed 42 out of 64. But when I did the other one, it did take one away.
Okay.
And I know it was one of these.
Okay, so let's go to the one that you have an X on. Or did you already expend all your attempts on that one?
No, I didn't.
Okay. So let's go ahead and fix that one. So it says, which of the following metals would you expect to have the smallest atomic radius? Okay, so if we have our periodic table, I have mine with me.
Oh, I could just pull it up right here.
I'm gonna, yeah, P table, perfect. See, you're genius there. Okay, so what are our options? So toggle, yeah, toggle to the CHEM 101.
So
Wrong tab.
Celsius.
There we go. So we have cesium, we have, and I'm gonna write that, I'm gonna clear our screen, I'm gonna write on the board. So we have cesium, we have barium, we have lanthanum, we have europium, and we have tilanthium. Okay? Okay, let's go to P table. I think you have to type it in again, Gabby.
Right here?
Go to P table. So go to, you need a, put another window. Because you
I
closed.
have, can you not see it? I have one, I have two open.
Oh, I only see the one. So I think you have to reshare your screen for us to see them all. Okay.
Can you guys see that?
I can see that. Yeah, I can see the
Yeah.
P table now. So I'm gonna write it again on your screen. So we had cesium. We have barium. We have lanthanum. We have europium, and we have. Okay. So these are the elements that we're looking at. Okay. So cesium, barium. So cesium is here. Here's cesium. Here's barium. Here's, and then we have europium down here, and we have lanthanum right here. Okay, so if we take a look at it, it goes here, down here, and then comes back up to here. So if you guys remember, we talked about this on Tuesday. Yep, Tuesday. So as we go from left to right, what happens to the size? Does it get bigger or does it get smaller?
From,
That one was,
Come on, you got a 50-50 chance.
it's smaller?
It gets smaller, that's right. Okay, so who's going to be the smallest? Because these guys are all on the same line.
Is this one.
Which one is this one? You have to circle it or something.
Oh, hold on. Because on the side, it goes from left to right, it's smallest, and then from bottom to top is smallest too, right?
Yeah, it goes from, you're right, that's right. So, well, not the smallest, from bottom up. Yeah, from the bottom to the top, it goes smallest. That's right. Okay. But all of these guys in theory are on the same line, right? So all of the ones that we've talked about right now are all on the same line. Do me a favor. You see where it says wide up top here? Click that. You got to do it again. And just don't double click it. Just click it once. There you go. Okay. So we have these guys here. I'll start from here. So you guys can see that they're all on the same line. And TA. Okay. You see that? Okay, so
Yeah.
which one is going to be the smallest, and which one is going to be the largest?
So this one, this one is gonna be the smallest, and then this one's gonna be the biggest.
No, because you just told me. You said as we go
Oh.
from left to right, it gets smallest, right? So which one is going to be the smallest?
This one.
Okay, so the TA is going to be the smallest. Okay, and then the cesium is going to be the largest.
Oh, okay, hold on. Let me read. I have it wrong. Yeah. It's smaller towards the end.
So if we started here, we go in that direction, get smaller, right? Go from left to right. Okay, so let's go to the question now and answer it. See if we're right.